Hello everyone, Jason here with Vise Edge. Today I'm going to be continuing on with the Tombstone for the MicroARC. And if you haven't seen the last video where I did the adapter plate, you should check that out, at least the beginning of it, because it kind of goes over all the things that we're going to be doing here. First thing I want to do is actually get this mounted to the adapter and put on the 4th axis so that we can take some measurements and see where we're at. That'll kind of determine where I go with the rest of the processes to finish this up. Let's go ahead and start putting this together. First thing I got to do is put in these bolts that are going to hold it onto the flange of the 4th axis. One of the reasons that I'm using these flanged hex bolts is so that I can get a ratcheting wrench actually in the spot to tighten it down. I designed it so that it would just barely fit one of these things, make it easy to take on and off. If I used a Allen head socket, it would be almost impossible to install because of the length of the Allen key. You'd have to have a really short Allen key to try to get in and tighten it down. So with the hex, you can just get in here, tighten it down, loosen it up, whatever you got to do. This will stay captive. Got to put all these in first because there's not enough room to take them out after. Now this will only go on one correct way. I've got a little mark here that I did in the machine that should line up with one of the flats. And I think it's that one. Nope. There we go. Got the mark lined up with the top of the flat. That's the way it should go together. Now the bolts that I'm using to hold together the Tombstone and the adapter are these flange bolts I got off of McMaster-Carr. I put a little bit of anti-seize on these because they're regular steel instead of stainless. I don't want to have any corrosion issues if I ever need to take it apart. Okay, that's together. I actually don't know what the torque on these is supposed to be. Let me go look that up. All right, so I looked that up. These 5/16 18 threaded fasteners are similar to a grade 8. So the recommended torque should be around 177 inch-pounds. McMaster-Carr doesn't show a recommended torque on their website. Would have been nice if they did, but that's what I'm going to go with. See if I can just hold this. It's not much torque still. Nope. Okay, got to put it in the vise or something. All right, just got a couple layers of tape on here to protect it. It should be fine. I'm not really torquing down on this very hard. All right, now I gotta move the vise over so that I have enough room to put this thing in. It almost fits, but not quite. All right, well, I'll just take it out for now. This thing's pretty heavy. It's got a little handle in the back, that's kind of nice. All right, got all that cleaned out. One thing I would recommend that everyone does is always have something in your spindle when you're cleaning off the table and blowing chips and stuff everywhere. You don't want to get them stuck inside there. This is just a a drill chuck adapter that's empty, so it doesn't have any sharp edges on it. Don't leave a sharp tool in there while you're doing it. It'll probably cut you in the head somewhere. I don't know how well you can see that, but there's actually a little bit of a light rust outline where the vise was. It hasn't actually even been in there that long, you know. It's maybe a few months. So we'll have to find a better way to keep it rust free. I just put some of the raw coolant, the unmixed, on the bottom of the vise and then put it on the table, but doesn't seem to quite have done it. I've actually got a few dings in the table already. You can see a couple of those there. This happened from a combination of things, either me just being clumsy and dropping things, but there was also a time where the machine was in the middle of a tool change, coming in and trying to grab one of the tools and hadn't locked in yet, and I realized that I hadn't set the 0 or something like that. I hit the E-stop, so what happens is this stops, but the tool changer actually will retract. Since it's not locked in, that will just it'll just pull the tool right out of the tool holder and drop it. So that's not great. It would have been much better if the tool changer would have stayed in place. If you hit E-stop, you would think E-stop means to stop everything, but it actually retracts the air cylinder on the tool changer. So I'm not sure if there's a way to fix that, but I'll have to ask Tormach at some point. Or I could just not hit the E-stop when it's in the middle of a tool change. You know, that might be a good idea. I think I caught it on film one time. I'll show you that. Shit. Yeah, so don't do that. And we'll have to stone these nicks out before I move the vise at all. I want to make sure it's nice and smooth and flat. Now what I'm doing here is just trying to flatten the stone before I use it on the table. This probably isn't the best way, and this isn't one of those special match sets you can get, although I do want to get some of those, but this will work for now. I'm just using the surface plate and a piece of sandpaper to level out the surface of it. And you can see my marks are starting to disappear. As soon as those are all gone, should be good enough. Sandpaper wears out pretty quick. Okay, I think we got it. You can hear the difference when you go across them. Doesn't actually take any material off of the table, so I can sort of check it with the razor blade to make sure if I feel anything, it'll catch. Nope. That's it. That's good. glides right across it, no problem. I'm going to leave this tool height setter here. It's already at the very end of the travel of the machine, so, and it's far enough back from the vise it should be out of the way of any material that I put in here. So I'll just leave that where it is and move the vise over enough to accommodate the tombstone, where it'll be sort of centralized. First, let's mount the tombstone on here, see how much room we've got. Alright, so the ratcheting wrench doesn't really fit in there very good. Need a little more space for it, but regular wrench works just fine. After you get it started anyway. Yeah, version 2 of this, I'll have to either make this cut out a little bit wider or sink it in a couple more millimeters to have clearance. Alright, so that's tightened down. Man, how cool is that? First thing I want to know is how much deflection I get when I push on this. So I'm going to put an indicator on here, push on it, see how much it moves up and down. That'll tell me if I need to put a bore in here for the tailstock bearing. Alright, got my indicator set up here. This is a 5/10 indicator, so each one of the lines on there is 0.5 thousandths. And let's see what happens when I push on this. Okay, so pushing on it pretty hard, I can get 2 thousandths of deflection. Yeah, I think that means I need to put the tailstock on there, otherwise this thing will vibrate all around if it's doing anything that's relatively heavy. So yeah, pulling it up I can get 2, pushing it down I can get 2 without too much crazy effort. So alright, that means we're going to be machining the bore down here and putting a bearing. The other thing I want to check in here while I've got it set up is the runout on this hole. This is a reamed hole that's 3/8 that I've already put in, and so it's nice and round. I want to see if it's actually in the center of rotation for the 4th axis. If it is, then I can use that as my 0 point for setting up the bore. I want to make sure that's exactly in the right spot. I might actually even be able to measure which direction it's off and compensate when I set it up for that other operation. Okay, that seems to be the spot where it's off by the most, and it's pretty much squared up with one of these sides, so that means that I think I can compensate for the off center, and it's 12.5 thousandths off in that direction. Okay, so that actually means that it's too far up by 12.5 thousandths. So if I move it down by 6.25 thousandths, that should put it right in the center of rotation. It's too far up. I need to move it down by 0.00625. So I can use the bore here to zero out and then move it 6 1/4 thousandths and reset my zero, and then do the boring operation for the bearing. So I got to take this all apart and get the vise set back up, and then I can do the machining on the face of this right here. This vise I have to put in this last channel because otherwise it hangs over the edge enough where it'll run into the back if it's at the end of its travel. So it's kind of unfortunate. You lose a little bit of range, but that's just how it is. Yeah, it's about 900 thousandths there, and about the same on this side. That should give me enough room to put a 10-inch piece of stock in here without running into any clearance problems. That's not bad. All right, that's within about 2/10. Try to tighten it down a little bit. I always like my vices to be as perfectly square as they can possibly be, so I spend a lot of time doing this. Probably way too much. There's a little bit of movement there at the end. It's only like 1/10,000th or something. I'll have to put my straight edge in and measure it over a longer distance. So one of the ways I like to check the vise tram, which is the straightness, is using a very good straight edge. This is a Starrett one, and I just put it in the vise on some parallels, make sure everything's nice and clean, and just barely tighten it down. Make sure it's all flat. Just to hold it in place, barely in there. And it's sticking up just enough for me to get the indicator on it and measure across a wider range. All right. So I got a little dip in the middle there, but across the whole, what is that, 10-inch piece? 12-inch. It's a 12-inch piece. It's pretty close. I'm just going to tap it around a little bit, see if I can make a slight improvement. Alright, so end to end, that's right on. For some reason in the middle here we've got a spot that's just a little bit higher than the rest of it by half thou or so, but it's straight. Alright, this is where we start to run into some issues. If I want to, this is a really tall piece of stock. If I want to run tool changes and have this clear, I either need to make sure all my tools are shorter than this height. So when it does tool changes, it'll pretty much stop wherever it is. It won't move it out of the way first. And it'll turn the carousel. If you have something too long, it'll clip your part. So you can see when it's in tray load position, it puts the tools right over the part wherever it stopped the machining. It'll just raise up from there. So you can see all my tools will clear except for that drill. So I have to make sure I've got that out of the carousel at least. There's a lot of different ways you can measure this center. I'm going to use this probe because I've got it set up and calibrated to where it's really pretty accurate. So I trust it. And I'm just going to probe the center of the hole, do that a few times. Okay, it's repeating to 0 every time, so we'll go with that. Need to move it over 6 thou and re-zero on the Y direction. We'll move the Y in the negative direction by 6. It's 0.00625, but it doesn't have that kind of resolution, so 0.006.2. That's what we're going to call it. There's my new Y0. All right, so I'm going to machine the bore for the bearing, and I'm just going to use one tool for it. It's just this. It's the same tool I've been using in a lot of the aluminum. It's this 3-flute 3/8 end mill, and I'm going to machine it to about 10 thou under, and then we're going to, hopefully my boring bar will come in sometime soon, and I can use a boring bar to finish off the hole. So here's my boring bar setup. It's a bit long, so I have to do manual tool change on it. But the way it's set up, it does tend to shake a little bit if you have the RPMs too high. So anything over 1,000 you could feel it on the outside of the enclosure. And I imagine that sweet spot will change depending on how you have the bar set up, whether you have it in this hole or that hole, or how far you have it moved over. The balance on this is going to change all the time. So there's my bored hole size. And here's the bearing that's going to go in there. So I've got a 5 10 thousandths difference. That will give it a press fit, but it won't be extremely tight. So that's just what I was looking for. It's turned out real nice. Okay, I got this all set back up in the 4th axis. It's all bolted down. This is where we find out how close I got this bore. Hopefully it's really good. Let's see what we got. Alright, got almost 5 thousandths of runout still. Let me try making sure everything's tightened down. Check it all again. Alright, so part of the problem I think I've been having is that these shoulder bolts are a little bit undersized to the holes that I have reamed in here. So, I don't know if you can see that. There is a little bit of opportunity for this to be bolted down in slightly offset. That's probably enough to account for the differences in the runout from that bore on the other side. Okay, so what I've decided to do is the bolts that hold these two pieces together, I left just barely hand tight so that I can bump this piece around to get this bore in the center line. That means that after I've tightened everything, I won't be able to separate these two pieces and put them back together without having to redo all that. So, lesson learned. We'll see if I can get this straightened out. Hopefully this will be it. I can tighten it down and then that'll be done. Well, I think that's about as good as I can get it. Just over 1,000th of runout. So go ahead and tighten that down and check it again. I'll just probably have to deal with that. So I got this piece of Delrin. I just turned down this side to the proper size on the lathe real quick. That should align everything. Let's see how that works. So this is as good as I could get. Just a little over 1 thou. I'm just gonna have to live with that. With this this version 1.0 Tombstone, without remaking any of this, I think that is as good as it can get. So that'll just have to do. We'll see if it has any effect on anything. So I can go ahead and install this bearing. But the good news is that after I have this thing bolted down, no matter what I do to it, it just goes right back to zero. It doesn't move at all. So that's good. At least it won't move after it's in place. And if I do take off the Tombstone as an assembly, it won't be a problem. It's only when I separate these two pieces that I have to reset everything. So next time I do one of these, I'll design in some better features for locating the two parts together. All right, there it is. It's in there. All right, so that was a little bit of an ordeal. I probably took this thing off 20 times to try to get the runout at the bearing end within an acceptable range. And I think we're there. The runout shouldn't be too much of a problem because I'm going to be machining everything in place anyway. So before I do any of that with the pallets and anything else on the outside surfaces here, I need to make the tailstock that will fit into this place right here. So that'll be all out of steel, and should be interesting. I haven't really done very much steel machining on this machine. So on the next video, we'll start working on the tailstock, and that's it for today. I'll see you on the next video.